An airplane has an airspeed of 430 miles per hour at a bearing of 135. So let's draw a north-south line. Start at the north and rotate clockwise 135 degrees. And this is our airplane represented as a vector. And the magnitude of this vector is going to be 430 miles per hour. But there's a wind blowing. The wind velocity is 35 miles per hour in the direction north 30 degrees east. So at the tail of our first vector, let's draw another north-south line, and we're going to turn from the north 30 degrees to the east, and this will be our wind velocity vector, and its magnitude is 35 miles per hour. And we are to find the resultant speed and direction of the plane. So we want to find the resultant, we'll call it R, and then we want to find the direction of the plane, which would be this angle. So I'm going to go back and work this problem using the things we learned in a previous lesson. Note that we have a side, 430, and we have another side which is 35, and if we look at the angle between them, we could use the law of cosines to find R. So R is going to be equal to 430 squared plus 35 squared minus 2 times 430 times 35 times the cosine of the angle between. So if we go back and look at our given information, our original bearing was 135 degrees, which means that this angle would have to be 45 degrees. And that angle is alternate interior to the angle in our triangle. And so that's going to make this total angle in our triangle be 75 degrees if we add the 30 to it. So this would be the cosine of 75 degrees. So that actually is what R squared is equal to, using the law of cosines. So R would be equal to the square root of this, 430 squared plus 35 squared minus 2 times 430 times 35 times the cosine of 75. And we can enter that all in our calculator, and we'll get that our resulting speed after the wind blowing is 422.297 miles per hour. Now we want to find the direction that the plane is actually flying. And so to do that, we're going to need to find this angle theta in our triangle, and we can use law of sines to do that. The sine of theta divided by the side opposite theta, which is 35, will be equal to the sine of 75 over the resultant that we just found, 422.297. So if we cross multiply, the sine of 30 times 422.297 will equal 35 times the sine of 75 degrees. So the sine of theta is 35 times the sine of 75 divided by 422.297. So theta would be the arc sine or inverse sine of 35 times the sine of 75 divided by 422.297, which if we enter that in our calculator is 4.592 degrees. So if our original bearing was 135 degrees and theta is 4.592, if we take 135 degrees and subtract 4.592 degrees, we'll get the actual direction of the plane, which is 130.408 degrees. So this is the bearing of our plane, and this is the resultant speed of our plane.